Hi, my name is Jenna and today I'm going to show you how to solve an energy problem. So the problem states, for this roller coaster track pictured on the next slide, the height at point X equals 30.5 meters. A loaded 200 kilogram roller coaster cart has 2.356 times 10 to the third joules of kinetic energy at point X and 1.342 times 10 to the third joules of kinetic energy at point Y. What is the total mechanical energy at point X and at point Y? And then what is the height of the track at point Y? So the first part of the problem is asking to find the total mechanical energy at point X. And so to solve this, we would need the formula to calculate mechanical energy, which is total mechanical energy equals the kinetic energy at point X plus the potential gravitational energy, which is equal to the mass of the cart times gravity times the height at point X. So to get the potential gravitational energy, we would multiply the mass of the cart, which is 200 kilograms, by gravity, which is 9.8 meters per second squared, by the height of point X, which is 30.5 meters, and gives you 59,780 joules. Now, to get the total mechanical energy at point X, we would put that number into the equation mechanical energy equals kinetic energy plus the potential gravitational energy, and have that the kinetic energy at point X equals 2.356 times 10 to the third joules plus 59,780 joules, which would equal 62,136 joules as the total mechanical energy. Then, to find the total mechanical energy at point Y, you would do the exact same thing and end up with 62,136 joules because they will both be the same since we're talking about the total energy of the roller coaster, which is always the same for both parts. So just as I said before, the total mechanical energy for point Y would be the exact same as it was for point X, since the total energy is the same throughout the entire roller coaster system, and you would thus end up getting 62,136 joules of energy as the total mechanical energy. Now the last part of this problem is to find the height of the track at point Y. Since we know both the kinetic energy at point Y and the total energy of the system, but not the potential gravitational energy, which would be used to find the height, we would substitute an x in for the potential gravitational energy value and have the formula kinetic energy at point Y plus the potential gravitational energy, which is the x, equals the total mechanical energy. So when substituting in the numbers, 1.342 times 10 to the third joules is the kinetic energy at point Y plus x equals the total energy 62,136 joules. So to get the x by itself, we would subtract 1.342 times 10 to the third joules from both sides and get the potential gravitational energy to equal 60,794 joules. Then to get the height, we would rearrange the potential gravitational energy formula to get the height equals the potential gravitational energy divided by the mass times the gravity, which would give us the height equals the potential gravitational energy, or 60,794 kilograms meter squared over second squared, times divided by the mass of the cart, 200 kilograms, times gravity, which is 9.8 meters per second squared, and canceling out the kilograms, second squares, and the meters squared to be left with only 1 meter, and get the height equaling 31.02 meters as the height of the track at point Y.